So, how do you know if something's hot or cold? I mean, it seems super simple, right? You just touch it. But what if I told you your own sense of touch is, well, kind of terrible at judging temperature? That's exactly what we're going to get into today.
All right, so let me ask you straight up. Can you really trust your hands? Think about it. Have you ever been outside on a cold day and touched a metal pole and then a wooden bench right next to it? The metal feels way colder, doesn't it? But are they actually different temperatures? Hmm, let's dig in. Okay, check this out. Let's start with a story about a kid named Lambuk. He's feeling a bit under the weather, kind of feverish, so his sister, Phoebin, does what we all do. She puts her hand on his forehead. It's the classic move, right? But even she knew that just touching his forehead isn't really enough to be sure. And that brings up the big question. How do we get a real, reliable answer?
And that's because, and you're about to see this for yourself, our sense of touch is, well, it's a bit of a trickster. Our hands are amazing at so many things, but giving us an exact, objective temperature, yeah, that's not one of their strong suits. They can, and they absolutely do, play tricks on us. So, to really see how much our hands can mess with us, let's walk through a super simple experiment. And seriously, you can try this at home. All you need are 3 bowls. One with warm water, one with some ice-cold water, and one right in the middle with just regular old tap water. Okay, first step. You're going to stick one hand in the warm water, and the other hand goes into the ice-cold water. Just leave them there for about a minute. What you're doing here is basically priming your hands, getting each one totally used to a really different temperature. All right, now for the big reveal. You're going to take both hands out and plunge them right into that middle bowl with the tap water at the exact same time. Now remember, this is key. Both hands are now in the very same water at the very same temperature. So what happens? It's totally bizarre. The hand that was just in the warm water, it tells your brain the tap water is cool. But the hand that was in the ice water, it feels that exact same tap water is warm. It's wild. You're getting 2 completely opposite signals from the exact same thing. So what on earth is going on here? Well, the key thing to understand is that your sense of touch doesn't actually measure temperature directly. Nope. What it's really sensing is the rate of heat transfer, how fast heat is moving into or out of your skin. So your warm hand is losing heat to the tap water, which feels cold. Meanwhile, your cold hand is gaining heat from the tap water, which feels warm. This is exactly why we need a better, more objective way to figure this stuff out. As the source material puts it so perfectly, we cannot always rely upon our sense of touch to decide correctly whether a body is hot or cold. So, if our hands are unreliable, how do we get to the objective truth? Well, we turn to science, of course. And the scientific solution to this whole perception problem is the concept of temperature. You see, temperature gives us a number. It's a reliable, consistent way to measure how hot or cold something actually is. And the tool we use for that? The good old thermometer. It just cuts right through all the guesswork and the tricks our senses play on us. Now, not all thermometers are created equal. There are different ones for different jobs. So let's start with the one we're probably all familiar with, the personal one, the kind we call a clinical thermometer. I'm sure you've used one of these before, a modern digital clinical thermometer. They're built for one very specific job, measuring human body temperature. And thankfully, they're a whole lot safer than the old mercury ones. You know, the ones filled with that toxic heavy metal? Yeah, good thing we moved on from those. Now, we've all had this number drilled into our heads, right? 37 degrees Celsius or 98.6 Fahrenheit. That's the magic number for a healthy human. But is it really that simple? Well, not exactly. And this is really interesting. That number, 37 degrees, it's just an average. It was calculated from a huge group of healthy people. Your own personal normal temperature can actually be a little bit higher or a little bit lower. It even changes based on your age or what time of day it is. Okay, but what if you need to measure something way colder or way hotter than a person? I mean, you can't exactly stick a clinical thermometer in a pot of boiling water, right? For that kind of job, you need a totally different tool. And here you can see them, side by side. On the left, you've got that familiar clinical thermometer. And on the right, that's a laboratory thermometer. They definitely look different.
And that's because they are built for completely different things.
So let's break down the differences. A clinical thermometer has a really narrow range, usually only from about 35 to 42 degrees Celsius. And that makes sense, right? Human body temperature doesn't swing around that much. A lab thermometer, on the other hand, has to cover a huge range, often going from -10 all the way up to 110 degrees Celsius. And using a lab thermometer takes a little more skill, too. You have to keep the bulb completely surrounded by whatever you're measuring. And this is important. You have to read the temperature while it's still in there. The second you pull it out, the reading will start changing. With these things, precision is absolutely everything.
Okay, so we've gone from our own bodies to a beaker in a science lab. Now let's zoom out, like way out. How do we take these same principles and use them to measure the temperature of our entire planet?
Well, you actually see this in action every single day when you check the weather. Those maximum and minimum temperatures you hear about in the forecast, they are absolutely crucial pieces of the puzzle that help meteorologists predict what the weather's going to do next. And when you're talking about something as big as the weather, accuracy is everything. This brings us to a powerful quote from Anna Mani, a pioneering Indian scientist often called the Weather Woman of India. She said, "Wrong measurements are worse than no measurements at all." She totally understood that having bad data is actually more dangerous than having no data at all. Her dedication to designing super precise, super reliable weather instruments was just revolutionary, and her work did more than just improve weather forecasts. It was a game changer that helped India become a world leader in renewable energy, like wind and solar power. You see? It all comes back to getting that measurement right. So we've seen how we can measure a fever, a beaker of water, and even the whole planet's weather. It kind of makes you wonder, though, are there limits to this? Like, is there a point where things just can't get any colder? And the answer is a big, definitive yes. The coldest possible temperature in the entire universe is -273.15 degrees Celsius. It's a point known as absolute zero. At that temperature, pretty much all atomic motion just stops. But here's the really mind-bending part. While there's a hard floor for how cold things can get, there is no known limit to how hot they can get. How wild is that? A pretty fascinating thought to leave you with.